everyone, welcome back to my YouTube channel. I am Roshni BN, studying in Sri Venkateswara College of Engineering, Bangalore, under the branch of Information Science and Engineering. My USN is 1VE23IS44 and my subject is Data Structures and its Application. Subject code is BCES304 and my topic for today's video is Single and Double-Ended Priority Queues. What are priority queues? A priority queue is a specialized abstract data structure that stores a set of elements which associated with a priority value. The key characteristic of a priority queue is that it allows you to retrieve the element with the highest or lowest priority at any given time. Its dynamic nature, that is, unlike a regular queue, which adheres to a strict FIFO, that is, first in, first out principle, priority queues prioritize elements based on their designated values. Elements are inserted and removed based on their relative priority, allowing for flexible management of data. Key properties of the priority queue. The core functionality of a priority queue revolves around the prioritizing elements. This prioritization can be based on numerical values, alphabetical order, or custom criteria defined by the application. Priority queues are designed to efficiently retrieve the element with the highest or lowest priority. The retrieval operation usually takes constant time, making it suitable for time sensitive scenarios. Flexible insertion. New elements can be inserted into the priority queues at any time, automatically adjusting the queue's organization to maintain the property order and its priority. Insertion and deletion in priority queues. Insertion. When inserting an element into a priority queue, the element is placed in its appropriate position based on its priority. The process involves comparing the new element's priority with existing element and finding its correct location within the queue. Coming to the deletion part. Deletion typically involves removing the highest or lowest priority element from the queue. The queue is then reorganized to maintain its priority order. The deletion process might involve shifting elements to fill the gap left by the removal element. Application of the priority queues. Network routing. Priority queues play a crucial role in network routing algorithms, where packets are prioritized based on factors like urgency or source. Event scheduling. Event scheduling systems leverage priority queues to manage the process events based on their scheduled times or priority level. Disk scheduling. In disk scheduling algorithms, priority queues are used to manage requests for disk access, prioritizing requests based on factors like data locality or urgency. Search algorithms. Priority queues are employed in various search algorithms such as star search to explore search places efficiently by prioritizing nodes based on their estimated distance from the goal. Structure and operations of single-ended priority queues. Single-ended priority queues are typically implemented using a heap or an array. The main operations supported are insertion and deletion of elements based on their priority. Insertion in a single-ended priority queue involves placing the new element in the appropriate position to maintain the priority order. Implementing single-ended priority queues. Heap data structure. One common implementation technique for single-ended priority queues utilizes a heap data structure. A heap is a complete binary tree that satisfies the heap property, that is, the value of each node is greater than or equal to the value of its children. For a max heap, or less than or equal to the value of its children for a min heap. Heap operations. The core heap operations are Insertion and deletion is a heap-based priority queue involve maintaining the heap priority and its property by performing EP5 operation. EP5 ensures that heap remains organized and allows for efficient retrieval of the highest for lowest priority element. Time complexity. The time complexity of insertion and deletion in a heap-based priority queue is typically logarithmic, as these operations involve traversing the heap structure, adjusting the element position to maintain the heap property. Advantages of single-ended priority queues. Single-ended priority queues are efficient for scenarios where elements are mostly inserted and removed from one end. They provide a single and straightforward implementation compared to double-ended priority queues. Single-ended priority queues are useful in scenarios where elements are processed based on their priority in the sequential manner. Structure and operations of double-ended priority queues. Double-ended priority queues are typically implemented using a doubly linked list or a balanced binary search tree. The main operations supported are insertion and deletion of elements from the both ends of the queues, null on their property. Insertion is a double-ended priority queues involves placing the new element in appropriate position to maintain its priority order. Advantages of double-ended priority. Double-ended priority queues provide more flexibility compared to the single-ended priority queues. They allow elements to be inserted and removed from both ends, providing efficient access to both the highest and lowest priority elements. Double-ended priority queues are useful in scenarios where elements need to be processed based on their priority in a non-sequential manner. Use cases for single and double-ended priority queues. Single-ended priority queues are commonly used in scheduling algorithms where tasks are processed based on their priority. Double-ended priority queues are used in scenarios such as managing event-driven systems or maintaining a sliding window of data. Conclusion: single versus double-ended priority queues. We will be discussing basically three features, that is access, insertion and deletion. Single-ended priority queue allows access to the highest priority element, whereas double-ended priority queue allows access to both highest and lowest priority elements. Coming to the insertion part in single-ended priority queue, elements are inserted based on their priority, whereas in double-ended priority queues, elements are inserted based on their priority. Deletion part in single-ended priority queue removes the highest priority element, whereas in double-ended priority queue removes either the highest or lowest priority element. Thank you. Do like, share, and subscribe to my YouTube channel to get more interesting and exciting learning videos from my side. Signing off by Roshni BN.